Hi, my name is Jenny Berkmeyer. This is the video for assignment 5. So I'm just going to jump right in here with the live demonstration. I'm going to start by running the leader, which acts as our server, and then down below I will run the workers, which act as our clients. Alright, so as you can see, the leader is waiting for the workers to connect. We need at least 3, but my program supports at most 5 workers. Worker 1 has connected. You can see that on the leader and on the worker. Same with 2 and 3. So they have connected and connected. It's going to wait 10 more seconds to see if any additional workers join, up to 5. Alright, so the 10 seconds have passed, and there are 3 total workers. We'd like to enter the problem to solve, and I'll just do a simple addition problem. I have entered the task, and the leader has sent the task to all 3 workers, and we can see them right down here at the bottom in the workers. So let's enter 6, 6, and to make it interesting, worker 3 will say this is 4. So the leader has gathered all the votes, has done the consensus, and 6 is the answer according to these votes. You can see there's 2 votes for 6, 1 vote for 4, and then it's been announced to the workers as well. Right there, there, and there. Okay, so let's walk through step by step and show the parts in each code. Let me quit and clear just so this is a bit easier to see each step. Alright, so right away I'm running the leader. Let's take a look on the left at the code. Right now it's starting on the port that we've decided, and it's waiting for the workers to connect. We need at least 3, but at most 5. So let's go ahead and come down here to the workers. And then here, once we start seeing the workers connect, we can see that they're accepting them here, and let's see, and then this on the worker side is where they're connecting to the leader over here. So I mentioned before that we do have the opportunity to wait for more people to join. That is right down here, this timeout. It's only 10 seconds to see if other workers want to join, up to 5 maximum workers. But once we have all our workers, we are going to come down here to enter the arithmetic problem or type quit. So 5 plus 5 is what I'll enter. And then on the right, we see that it sent the task to all the workers. On the left, we see right down here that it's sending the task to all the workers, and then it actually does that through here. Workers sending the messages. I used the buffer read, and then I used the print writer to be able to communicate between the server and the clients. But let's see how that looks on this side. Right here is where it's receiving that task, and then right here we can see where it's asking us to enter the result. So let's go ahead and enter some results. Okay, so right here we sent the results to the leader, and we can see that right on this line. Once we sent the results to the leader, that's when this consensus algorithm really kicks in. So let's take a look down here. Oh, sorry, I've lost my place. One moment. Okay, so we're going down to the consensus results. So these consensus results have taken in the information that they got from the workers, just to make sure they're valid, and then it sends it right over to determine consensus. This is really where the magic happens. Every time there is a number that is sent to the leader from the worker, that number gets one vote. So on the right hand here, we have 2 10s, and you can see the vote counts right here. 1 vote for 5 and 2 for 10. That's how we determine which one has majority and which one's minority. The majority rules, the majority is the consensus. This algorithm also determines if there's a tie, which is more important when there's specifically 4 workers involved. Then the consensus has not been reached and the user is just asked to try again instead of trying to run the consensuses again and get the same answer. Once a consensus has been determined, then it's printed on both the workers and the leaders, and then it automatically goes into the next round. So let's add another worker here to see what would happen. So quit a clear. So I'm gonna add another worker, but it's gonna get even smaller down here. Let's see. Run leader, run worker. Okay, so we have worker 1 connected, worker 2 connected, worker 3 connected. It's gonna wait for that any other workers for 10 seconds, and worker 4 is connected. Alright, so all 4 workers have connected. Let's enter in a problem, and then we can see that all workers have been given this task. So let's see, I will do 6, 6, and then 8, and 8. But before I hit enter for this 4th worker, I just want to pause and explain what has happened so far and what I expect to happen. So far we've been able to connect the workers to the leader, and the leader has sent all the workers the task. From here, 3 of the workers have sent the leader their results. So we can see it here, 6, 8, and 8. I haven't sent that 4th worker yet, but I anticipate that when I do send that 4th result, that because we have 2 6s and 2 8s, that there will be a tie and that the user is going to be asked to try again. Let's see. So great, there is a tie, consensus has not been reached, try again. So again, it's showing me down here on the workers as well that there's been a tie and that we should try again. So for failures, we have various error messages throughout this whole program, but specifically for messages that are sent and received, let me find an example. Just a moment here, sorry. Okay, so in this consensus results, this is a good example. So if there is an error from what the worker is sending to the leader, then we're just gonna get these this exception message. And that's kind of the same for on the worker side as well. There's a few exception messages and connections messages if there is some issue. And then for the system state visibility, we've already went over how the messages are sent and received and the current state of the leader and the workers. And that is it.